Okay, in this one, I'm going to draw a free body diagram of this knot right here. Now there are three strings coming out of that knot. There's the one going down, the one going to the left, and the slantways one. Whoa. And I can label them. Let's call them T1, T2, and T3. Now I know a little more about T2 because I can draw a free body diagram of the fish. So here's the fish. We have mg pointing down, and we have T number 2 pointing up. So that means if I make the one and only equation that I can make from this picture, I would say T2 minus mg is equal to 0, so that means T2 equals mg. Okay, so back in this diagram, they tell us that this one here, T1, is fastened securely there, but this one will pull out of the wall after a certain amount of tension. That essentially means that they're telling us what the maximum T3 equals. So you were given some number in the problem, some number of newtons, and so we know what that is. And so all we have to find out here is what the mass is. And so let's let's write some equations from this free body diagram. So there's my y-axis and there's my x-axis, and I see that I have one vector flat on the x, one vector flat on the y, and one slantways vector. That means I need to find this angle right here between the slantways vector and the x-axis. That's the angle here, which I'll call theta, and theta was given in the problem, so that's a number that we know. All right, so let's write some equations. In the x direction, I have my one horizontal vector, T1, but it's negative. And then I have T3 cosine theta. Remember, you know what theta is. And this one's positive because it's to the right. And these have to add up to be 0 because this knot here is not moving. Then in the y direction, we have T2 is flat on the y-axis going in the negative direction, so that goes like that. T3 is the slantways one, so we're going to have T3 sine theta in the y equation, just the same way we had T3 cosine theta in the x equation. And this time it's going to be positive because it's up. And that has to add up to be 0 as well. Now, what we're looking for is mg. And we know that T2 is equal to mg. So let's put that in here. mg minus mg plus T3 sine theta is equal to 0. Okay, well we still can't solve that equation because we don't know what T3 is yet. So let's see how we can make a substitution. We do know, T3 is the one that we know. So that means that mg is equal to T3 sine theta. So m is equal to T3 sine theta over g, and we're done.